Hello, my name is Serdar Kaya. I am the Managing Director of Green Energy LLC. Green Energy is a Delaware registered company in US providing consulting services to oil and gas companies around the world. However, we have decided to shift our focus recently to renewable energies, especially geothermal. And today I'm going to present you the effective geothermal exploration, production, and energy extraction techniques. This is my outline I'm going to follow. First, I will introduce you the basics of the geothermal, and then we will talk about the current utilities, exploration techniques, production, and energy extraction that's available currently in the industry. Geothermal is a combined world. Geo means the earth, and the thermal means the heat. The mass inside the core of the earth is extensive amount, huge volume, with the very high temperature. That's why it acts like infinite source of the energy. And it is underused, underexplored. It's a clean energy. It's a cost-effective, infinite heat source. Is a reliable, available every time of the day and the year. So it's sustainable. And most important, it is environmental friendly energy source. The potential of this source, it can mitigate the global warming and reduce the environmental pollution significantly. But the limitation is there because of the geologically availability is limited. So the Earth's core maintains, as I said, extensive temperature, more than 5,000 degrees. The way that this heat is transferred to the surface could be a radioactive decay of the elements, conductive heat flow, or convective flow of molten mantle rocks to the crust. The volcanic activity transports the hot material to the surface. Only a small fraction of the molten rock can actually travel to the surface. That's why we have to reach to that hot material through drilling instead of waiting the molten rock to come to the surface. And hydrological convection forms the high temperature geothermal systems at shallow depths from 500 meters to 3,000 meters. The geothermal system is actually formed by three components. These components are heat source we have to have available, and this heat source has to be existing inside a reservoir, which has the porosity and permeability for the hot fluid to travel. And we say the water should be also existing inside this reservoir with the heat source to form a geothermal system. For exploration, for discovery of a system, we believe we have to have a multidisciplinary approach is adopted. Multidisciplinary is hydrogeological, geochemical, geophysical, petrophysical, geological. Knowledge has to be existing and cooperating together to economically and profitability, high profit operations has to be adopted. Otherwise, from one discipline, one side of the issue is not going to be solving the challenges easily. So the exploration techniques, some of the measurements we are using is gravity surveys, magnetic surveys, indirectly to understand the crust, and then directly we can measure the heat, the temperature by resistivity or conductivity electricals. This technique can measure actually, and then it can tell you also the depth of the temperature. However, none of this technique is definitive unless you derail and find it directly. So geochemical analysis basically is the measurement of the chemical or gases to indicate the available source. Seismic methods gives information about the subsurface formations, the rock types, and the change in the geological behavior of the rocks. Hydrothermal alteration is the heat change, the gradient of the heat inside the formations. Tectonic settings and the geological history of the area also tells us a lot of information about the availability of the geothermal sources. So as I said, we need water for heating, okay, underground reservoir. So this is a huge source of water. It has to travel to the heat source and through the fault systems comes to the surface sometimes as a surface manifestation. So from this system, we extract the energy. And then to be able to extract energy, we need to have a surface facility. So by combining all these components, the geothermal system forms and produces clean, sustainable energy for the human activities. Exploration and production techniques basically is around the geology, geophysics, but we believe a 3D geological model, if a company or the group of the people who are investigating the geothermal sources, if they can build a geological model, including hydrothermal parameters, can provide a better subsurface picture to reach the conclusion and the results. So high pressure, high temperature system underground travel to the surface, and in the surface, we have different scheme of energy extractions. It can be power generation or using the hot water for different applications like wood drying or inside the greenhouses for heating or residential heating. There are different ways of using geothermal. Even tourism is also a good way of an application, geothermal application. So as I said, the hot material, hot fluid travels to the surface, which is high temperature, high pressure, and goes through the turbine, and then the steam or the material water is re-injected back to the subsurface reservoir. As I said, the crust with high temperature and the mass, the huge mass, acts like an unlimited sources. And in this geothermal energy extraction, there is no pollution, almost no emission and no pollution. 100 megawatt of geothermal source eliminates 560,000 tons of CO2. So this is extensive reduction of the pollution. And no sulfur or nitrogen contamination, no drought, no seasonal availability. During the day or in winter or in summer, it's always available. Not in solar, for instance, nighttime is the unavailable time, or in wind turbines, we need to have wind always available in the system to produce. However, geothermal sources are unlimited and available all the time. The surface facility really does not occupy a big space like a refinery, like the oil production facilities, surface facilities. They need extensive surface availability, and then they have a lot of pollutions. In geothermal, you need a simple building, including the turbine and generator. That's all basically, and few wells. And the lifespan of a geothermal system is short. It is very long. Okay, so the sustainability comes from the lifespan. So the disadvantages or the problems, the troubles of the geothermal, the geographically availability. It's not available everywhere. So I'm going to share with you where it is mainly in the world available. It is the cost of the drilling might be initially a capital cost, but after drilling phase, there is no operational expenditure is really low. Although I told that there is no emission or pollution, sometimes the produced steam might have some nitrogen or some sulfur. However, a closed system, closed loop of injection, reinjection back to the reservoir can solve this issue. And the other environmental problem might be the vibration of the system due to very high pressure and temperature. The mechanical parts can produce the vibration, and it harms or it generates the voice pollution. So the discovery of or the exploration of the system starts with the surface manifestation. Hot water springs or volcanic activities in a region is good indication. So that's where we can start if we want to explore in a country or in a region. So we can look at the sources of hot water spring or volcanic activities, fault regions, earthquakes. All these are good indications of the availability of the geothermal system, geothermal reservoirs. So we use geothermometry, geophysical techniques like magnetics, self-potential, resistivity, microgravity, seismic. All the oil and gas exploration techniques can help us also here to identify the reservoir. Geoscience and the surface investigation, temperature gradient pulse. As I say, you never know before you're drilling. Whatever the geophysical, geological exploration techniques, it tells indirectly or directly the parameters. However, the absolute result is obtained by a drilling. But at the beginning, in order to make a discovery, avoiding the high cost of the drilling, we can open a slim hole and identify the temperature inside the reservoir. Then we can go normal drillings, high, the size of the pipe, size of the drill bed can be much higher in order to produce much higher volumes of the hot fluid. Then, as I said, the production size of the well can be higher. And then instead of having couple wells, we can increase the number of the wells in order to increase the number of quantity of the hot fluid to generate more power. So the surface facilities is formed by the production wells, and the produced fluid has to be either used in the surface, otherwise has to be re-injected back to the reservoir. Actually, to use the reservoir fluid back to the reservoir is a good idea in order to avoid the contamination in the surface and also inside the reservoir, because the reservoir is a complex system with the porosity permeability. If we inject some other fluids, it can also plug the pores of the reservoir or harms the reservoir and then stop the production. So using the reservoir fluid back to the injected is a good idea, and make sure that the reservoir is going to maintain the flowing system, the cycle system. So to generate the power, we can have the base load plant or peak load plant, which means the capacity of the plant can be only maintain the base load, or if the peak load is required from the surface facility and the capacity is built accordingly. Steam gathering lines, if we have multiple wells, we have to have on the surface, this steam from the wellhead to the facility has to be transferred by the isolated pipelines. In order to avoid the temperature loss in the fluid, we need to use the isolated pipes. And then the produced power from the plant has to be connected to the transmission lines of the power. So we have to have also the connections for the power transmission. So this is the map showing the generally the high potential power plant, geothermal power plant. As you can see from the Pacific Ocean, East Coast and West Coast has the main points, while we are having in the Atlantic Ocean few locations, and the east side of the Africa in Turkey. These are the main geologically available locations. This shows you the surface manifestation around the world. Few examples I like to put in the slides for tourism. It's a good source, okay, for health purposes, it's used. So this shows the general schematics of the power generation. So the high pressure steam is transported to the turbine and rotates the turbine, which is connected to the generator for power production. And the fluid coming from the reservoir with high pressure after turbine, the temperature drops, the pressure drops, and needs to be reinjected back to the reservoir to increase the temperature inside the reservoir with the heat source, and then a cycle of rotation is formed. So based on the depth of the heat source, there is 3 different applications. In shallow depths, like 30, 60, 100, 150 meters, the temperature of the crest is used, like heat pump. Always the subsurface temperature in winter is higher than the surface temperature in winter, and in summer lower than the surface temperature. That's why it can be used for heating and cooling. In deeper formations, like up to 1,000 to 3,000 meters, the heat extraction is generally through the fluid is obtained, okay, from the reservoir, and we produce the fluid and get the heat extracted from the fluid and re-inject it. More deeper formations, 5,000, 6,000 meters, it doesn't have the access to the water, but it has the hot dry rock. So if the porosity permeability is good inside the reservoir, we can inject the water and get the steam back from the production well. Hot dry rocks also is good source of geothermal. So on the surface, there are different schematics to use the energy of the fluid. This is a dry steam schematics. The steam is generated, produced from the reservoir, goes through the turbine, and inside the condenser, it's cooled down to be water back again and injected. The reason that we are cooling inside the condenser is to reduce the volume, okay, from high temperature environment to the low temperature environment. It reduces the pressure. Sometimes phase change is required, sometimes not, but cooling is the objective of the cooling is to reduce the pressure. This dry steam power plants works at a temperature of 180 to 225 degrees, produces, and the pressure is up to 1000 psi. Steam is used to drive the turbo generator and re-inject it back to the subsurface reservoir. And 1 kilowatt is generated from 6.5 kilograms of the steam. What you see here, is single flash steam schematics. The steam is generated produced from the well, comes and goes through the turbine, and then condensed, and then re-injected back to the reservoir. So this is a summary of how the single flash works. Steam with water is extracted from the ground. Pressure of the mixture drops at the surface. More water flashes to the steam. Steam is separated from the water and then goes through the turbine. Then turbine drives the electric generator, produces the power, and the generation between 5 to 100 megawatt with the single flash system. This is double flash. It has two turbines, okay, high pressure turbine, low pressure turbine. It's connected to the generator. But as you can see, double flashing of the steam is obtained because of the high pressure, high temperature is used 2 times to extract more energy, actually. And the rest of the system works similar to the single flash. In binary system, the reservoir fluid comes to the surface and through a heat exchanger transfers to another fluid, which turns the turbine, and then a condenser reduces the volume and the temperature of the working fluid. And each system is a cycle and closed cycle. So it rotates, so the cycle works within the cooling, heating, and the reservoir system. In combined system, combined schematics, the steam turns the turbines in one hand. On the other hand, after the turbine, the fluid still has some temperature, which is extracted from a heat exchanger to an ORC system, which is organic Rankine cycle, can work from 70 degrees to 100 degrees still, because the working fluid is already a gas, and inside the heat exchanger, it expands, and the turbines, ORC turbines, with this expansion of the gases, rotates. So both sides in combined system increase the generator's production. In hot dry rack, as I said, there is no fluid inside the reservoir. It's very deep, there's no excess, there is no connection to the surface water sources. That's why we have to inject. We have to inject water, and this water is heated up, turns into steam, and comes to the surface. In hot dry rack, the objective is to reach more than 200 Fahrenheit, even more than that, in order to obtain steam, and the pressure of the steam is used. However, as I said, if the temperature is low, 70, 80 Celsius degree, we can use ORC organic Rankine cycle and still generate the power. Some of the other applications of the geothermal sources, we can use it for aquaculturing, horticulturing, thermoculturing. Inside the warm water, we can produce fish or prawns. And then we can use it for agricultural other operations like timber, wood drying, or greenhouses in agriculture. Greenhouse heating is significantly used in Turkey and other geothermal countries where available. So in food processing, steam can be used to sterilize the food processing facility and then dry out the foods drying, fruit drying, or vegetable drying. Preserving the food without any unnatural additives can be achieved. And then some other applications that comes to my mind right now, for instance, the steam, by using the temperature of the steam it reduces, and because steam does not have any dissolved material, it can be pure water. So pure water can be used for different industrial applications, or even hygiene water can be used in the hospitals for disinfection. So after using for power generations, the temperature drops. However, at that temperature, like 70 degrees, 60 degrees, 40 degrees Celsius, still there are possibility to use it for greenhouse heating, residential heating, commercial heatings at that temperatures. So there are multi-stage utilities for power generation, for greenhouse, residential heating, and then using in the agriculture as possible. And still it's applied around the world. For shallow depth, as I said, 50, 100-meter depth of the crust is a good source of energy because the temperature difference between the subsurface and above surface. And this is used generally in very cold countries to heat, at least to reach some kind of high level, high temperatures, and then again, reduced energy, low energy is used to reach like, heating level of the residential. So instead of heating a very cold water by using this subsurface heat at 50 meters or 20 meters depth, can be additive energy and reduce the cost of the heating or cooling also. So electricity generated is a significant help and support as a renewable source. So those countries that's on the top is the United States, 3,600 gigawatt is obtained in year 2019. And now if we find the numbers much better, the top 5 countries are United States, Indonesia, Philippines, Turkey, and New Zealand. And right now I feel that the oil industry is trying to shift some other renewable sources like BP, Chevron. They are every day announcing new projects as wind turbine farms, solar farms, and then geothermal, because of the drilling, is already experienced disciplines in the oil and gas industries. And even the oil and gas reservoirs have high temperatures. When it comes to the surface through the well bores, still that has high temperature can be used in an ORC system, which doesn't affect the oil production, but use the temperatures. There are, by this shift happening in the industry, I believe much higher gigawatt of the production is going to be achieved in a short period of time, and we will see. So as a conclusion, I say geothermal heat sources provides unlimited free energy with almost no pollution, no emission, and there is no problem of the drought or seasonal availability, which is the sustainability of this investment is ensuring the investors. Multidisciplinary approach would generate tremendous potential for untapped geothermal sources. And various energy extraction and industrial agricultural applications have already been developed, and more is on the way, as we have explored during our presentation right now. For instance, I said the steam is used for power generation, drops the temperature, and turns into water. The water is pure. Hygiene water can be used in the hospitals. So this kind of applications is going to be discovered, developed, and increased the importance of the geothermal in a short period of time, I believe. It was my pleasure to present this, and I hope I have been able to share my experiences and knowledge in oil and gas industry. And I believe the future is going to be brilliant if we pay good attention to these geothermal sources. And I'm ready to answer your questions right now.